Okay, so we're gonna name the height as the h and then draw the box again. So 3x by 2x and the height is h, or you can use the y variable if you like. And then the volume that we know, the volume gonna be 24 inches or cubic inches, which is from the length times the width times the height equals 24. That means the height in the terms of the x gonna be 24 divided by 6 times x squared. Okay, because 3x times 2x is 6x squared. And then simplify h to be, I'm gonna write it, h equals 4 divided by x squared as the relationship of the height and the unknown x variable. The problem asks you to find the height that minimize the cost. Okay, the key term, the cost is called the objective function, or the function that we're gonna have to find the critical number. So then we're gonna form the cost function based on what we know. Okay, the cost function, since the cost depends on the size of the box, for the bottom and the top, the cost is $1.70 per square inch. So that means our cost function gonna be the cost of top and bottom added by the cost of 4 sides. Okay, are you okay with the setup so far? I mean that the framework so far.
Mhm.
Yeah, and from the figure that we drew, that I drew, so I have the top as the dimension like 3x by 2x, but I have two of them because the top and bottom, right?
Mhm.
And then for the 4 sides, gonna be the side that we have 3x multiplied by h plus another opposite side that 2x multiplied by h. Does it make sense? So we have 2 of the 3x by h and the other 2 for the 2x by h. Does it make sense? So this one and the opposite side gonna be 3x by h. And then this side and the opposite gonna be 2x by h. You guys okay?
Yeah.
Yes? No?
Yeah.
Oh, okay, follow so far. So the cost is 2 times the 3x by 2x. And the cost of this is $1.70. And then for the size, we have 2 of the 3x by h and the 2x by h. And then for the area, for the size, gonna be $3.60. Okay, so I should put in the right way, in the same way as this one. So this gonna be the area of top and bottom, and this is the cost per square inch. Okay, and this one gonna be the area of 4 sides, and this is the cost per square inch. You guys okay so far?
Mhm.
All right, cost per square inch. And next, the next step, we just simplify the numbers and the term expression in x. So we have 2 times 3 times 2, that's 12 times 1.70. So put in the calculator. Let me put in the calculator real quick here. Oops, have to do the wheel. Let me pause share real quick. resume
Or
recording. Say it again. What you say?
is that
20.
20.4 x square, right?
20.4. Yes, x times x, that's going to be x squared for the first group. And then the second one, do the same way. So going to be, going to move it over. So going to be 2 times 3. And then actually 3 plus 2, that's going to be 5. So 2 times 5 times 3.6. And that is 36. 36x squared times h. Okay, because this portion, that is 5x. Now the cost is in both x and h. So we're gonna go back to look at the h in terms of x. So we have h is 4 over x squared. We're gonna replace this one with 4 over x squared. Now we have cost equals 20.4 x squared plus 34 times 4 is 36, sorry, 36 x squared times 4 over x squared, and x squared reduce. We just have to compute the number 36 and 4.
Can I ask you some question?
Yes, go ahead.
So when you
What I missed. So it means 36 times x times 4 over x squared. Okay. Then the cost now becomes 20.4 x squared plus and 36 times 4. What do we get here? 36 multiplied by 4. We get 144 over x. So that's a cost function for this problem. Okay. And now the cost is in terms of x as 20.4 x squared. And I'm going to rewrite it as the power negative. So this is the cost function. And then our goal is to find out what is that minimize the cost. So we're going to find the critical value by finding the derivative of the cost function where the slope is 0, right? The slope is 0, or the lowest point of the curve. Gonna be 40.8 times x minus 144 x to the negative second, which is 40.8 times x minus 144 divided by x squared. Okay, rewrite it as one fraction. So gonna be 40.8 times x to the third minus 144 all divided by x to the second. So this is the derivative of the cost function. And we're going to look for the critical value where, so we know that the x cannot be 0 because if x is 0, so no box, no dimensions. Now we're going to look at the case at c prime equals 0, or the case at 40.8 x to the third minus 144 equals 0. And then solve for x. X to the third is 144 divided by 40.8. And then we're going to take the cube root of 144 divided by 40.8. All right. The number that we get is going to be the x value that we're going to use to find the h eventually. I'm going to clear this one. The quantity 144 divided by 40.8, and then raised to the power 1 over 3, which is the cube root. So you have x as 1.52. The problem asks to round to the nearest 100. So we're going to keep 2 decimal places. Okay. So x is 1.52.
I have a question.
Yes. So since the h is, recall we replace h with the 4 over x squared. So the h 4 over x squared. So that means this is 4 over the quantity 1.52 squared. All right. And put in a calculator. So 4 divided by quantity 1.52 to the second power, that 1.73.
That's final answer.
What's that?
That's final answer. 1.7.
The final answer, yes, that's the height, so 1.73. And you can check the solution on the last page of the practice problem as well. It's the same. So it comes out to be 1.70 inch for the height. That will give the minimum cost for this situation.